Okay, Assalamualaikum guys. So hari ni apa yang saya akan share adalah what does it mean by negative and positive relaxed static stability. What's the difference between commercial plane and fighter planes in terms of stability, dan juga what is fly-by-wire and also as what is F-14 with glove vein. Okay, fine. So let's find out. Okay, Assalamualaikum warahmatullahi wabarakatuh. Selamat bertemu kembali. So hari ni saya nak cakap pasal topik flight stability and automatic control. This is not my expert sebenarnya. ini saya rasa lebih kepada mereka yang involved in the automation lah. Tapi saya nak cakap hari ni the application in the automatic control dalam new ataupun fighter punya development. Jadi sebelum tu, so this is example of study yang kami belajar dulu. Topik dikenali dengan flight stability and automatic control. So flight stability and automatic control untuk fighter plane dan commercial plane is totally different. So dalam commercial plane nanti kita akan belajar bahawa commercial plane adalah we call it statically stable type of plane, whereby in fighter plane kapal terbang pejuang adalah we purposely design the aircraft to be statically unstable. So I'll be discuss that in the next slide. So sebelum tu let's go through one by one. So flight stability and automatic control. So when you talk about stability, there are what we call it the static stability and also dynamic stability. So dynamic stability is referred to the time domain. So where static dynamic is tak refer to the time domain. Jadi kat sini kita I'll talk about what is meant by the positive static stability, neutral stability dan negative static stability. And for the dynamic stability also, we'll go into what known as positive dynamic stability, neutral dynamic stability and negative dynamic stability. So seperti yang saya mention just now, so ada statement kat bawah ni, dia kata some aircraft are built to be very, very stable, but others like fighter jet tend to be very unstable. So we design it purposely to be unstable, making them highly maneuverable and easy to pitch, roll, yaw aggressively, and can even be unflyable without the help of computer control fly-by-wire system. So mungkin you have heard somehow term we call FBW, fly-by-wire. What is fly-by-wire? So this is general dulu about overall when the command between static and dynamic stable. Nombor satu you boleh nampak kat situ adalah what you call it statically and dynamic stable. Tapi nanti saya akan break into static and dynamic part by part. So in general kalau you nampak kat sini, okay, once the plane is deviate ataupun differ daripada straight flight path, so they tend to somehow oscillate. So kita tengok kat sini, oscillate is faster, and then as time goes by, this is what you call it dynamic domain. So the oscillation ataupun the oscillate tu will be slowing down, very stable. So whereby the statically stable and neutrally stable, dia will be constant. Dia punya oscillation tu will be swing forever. So whereby the statically stable, dynamically unstable is whereby dia akan will be bigger and bigger. So the A is referred to the commercial plane. The commercial plane, whereby when we design the commercial plane, we want the commercial plane to be statically and dynamically stable. Whereby when we design for the fighter plane, we want it to be statically stable but dynamically unstable. So this we'll discuss later on. So what we call as positive, so kita divide into static dan dynamic. Dynamic adalah time domain. So static stability, kita ada neutral stability, dan negative static stability, and then later on kita akan cakap pasal positive, neutral and negative dynamic stability. So if I can buat apa ni, the terms, kalau positive static dynamic stability ni, kalau kita boleh buat analogi adalah, contoh kita ada bowl dan kita ada bola kat tengah-tengah. So if you move the ball to the side of the ball, once we release it, so dia akan swing back and bounce back and forth, and until at the end dia akan stable at the center of the ball. So this one we call it positive stability. Bila kita kata sebagai neutral stability, is consider if we have the ball and then we tend to move that ball to some other place, so they will stay at that place. So dia tak move, so they will be stay at where it plays. Whereby yang kat atas tadi, they will be swing back and forth, and then be best equilibrium at the center. Tapi kalau kita define as negative static stability, ball tu kita buat macam terbalik. So bola tu dekat atas, then once we start roll the ball to the left or to the right, dia as fast as possible dia akan move to the most left or to the most right. So what does mean the difference between nombor satu positive static stability and negative static stability yang as I mentioned kat sini adalah, kalau commercial plane, when we design a commercial plane as such that when the commercial plane tu the pilot try to change dia punya position, either bang to the left or to the right, ataupun pitch up ataupun pitch down. So once the pilot lift the control stick, the aircraft sooner or later will balance back. So positively statically stability, dia akan tend to back to the normal path flight. So whereby on the negative static stability on the fighter plane, so negative ni ada refer to fighter plane. So once let's say we swing to the left, to the right, so bila pilot lift the control stick, the aircraft will be right way move to the right. So kalau to the left, so dia right click. So whereby tadi yang positive stability, dia tend to be stable back. So of course we need that for the pilot. Kalau tak, so waktu dia being chased behind or etc., dia tak nak turn lah. So the pilot want to turn tapi dia tak nak to turn. So they need to be very responsive. So once I want to make to the right, so right away is tend to move to the right. Tapi bila kita kata on positive static stability, it can become positive dynamic. Positive static stability can be neutral, and positive static dynamic can be negative dynamic stability. So this is time domain. So the time domain meaning that, so when the aircraft is tend to, let's say, deviate daripada straight fast flight, so dia akan oscillate as such that dia akan oscillate to be positively dynamic stable. Dia akan will be try to be tend to the rest in the normal flight. Kalau neutral dynamic stability tadi, kalau ingat dalam gambar raja tadi, so dia akan swing at the constant amplitude, theoretically forever lah. Okay, so once we deviate, this type of plane will be neutrally dynamic stability. They will tend to oscillate and forever. So I guess you can guess what we mean by negative dynamic stability. So when we deviate daripada the normal path, they tend to oscillate, then the oscillation will become bigger lah. Okay, it will become bigger. Alright. So when we say that neutral static stability, so dia once it move to one side, will be there. Yeah. Oh, dia disturb sikit. So if we move the other side, they will be there. So dia tak ada effect in terms of their oscillation, either positively dynamic atau neutrally dynamic ataupun negatively dynamic, ya. So they will stay where you put the plane R. And when we say about negative static stability, when we talk into the dynamic punya terms, so when we deviate daripada normal path, so they can be haywire elsewhere. So okay, so that's the term that we refer to the positive static and neutral dan juga negative stability, ya. So as everybody, okay, for those yang tahu, this is the F-16 Fighting Falcon, 1970s fighter plane. So as I mentioned just now, adalah semua commercial plane meant to be designed as positive static stability, whereby the fighter plane will be meant to be designed to be negative static stability. When it will turn right away, so deviate totally daripada fast. So it has to be responsive. So for the commercial plane, okay, for the commercial plane, what normally done in the commercial plane to design the positive static stability, so the center of gravity for the commercial plane, kalau saya boleh lukis the commercial plane, okay, the commercial plane, dia punya center of gravity is always in front of dia punya, kita panggil AC, aerodynamic center. So kita ada apa yang kita kenali sebagai aerodynamic center dan juga CG. So CG ke bawah, so then kita ada AC adalah aerodynamic center. Aerodynamic center adalah refer to the center of the lift which created by the wing. So for the commercial plane, in order to develop positive statically stable, so the CG has to be in front of the AC. So mana kapal terbang commercial was designed that the CG berat dia adalah di depan dan wing tu di belakang untuk lift dia. Tapi untuk fighter plane, because most of the total weight adalah berada pada engine, alright, dia punya AC dia adalah di hadapan dengan CG. So CG adalah di belakang dan AC-nya adalah di depan. Okay, so all the fighter plane was designed to be negative static stability by having AC in front of CG. Okay, so in case of the F-16 was the first plane. Actually, F-16 was known as the electric jet, whereby because F-16 was the first plane to be embedded ataupun di-design with the FBW lah, fly-by-wire, way back in 1970s, early 1970s. So whereby they use the flight control computer system untuk compensate the flight, supaya walaupun dia negative static stability, it has to be controllable. Kalau tak haywire lah. So that's why the computer, the fly-by-wire needed to do all the correction for so much of deviation because of the negative static stability. So saya ada dapatkan satu video, so you can refer to the video as I shown there. Okay, this is F-16. Mereka buat test pilot tengah buat testing on the F-16 untuk untuk perfectkan the flight control stability mereka. So this is where when bila dia off the flight control system, and they'll see that the negative static stability of this F-16 will be uncontrollable sebab komputer dia off. So this one dia off, so you can see that the F-16 will be difficult to control lah. negative relativity, so I say negative RSS, negative versus positive RSS. So for the F-16 actually is having a tendency of pitch up, okay, in the low speed flight, because the AC is in front of the CG, okay. So tapi the AC actually created on the wing will tend to move backward as the speed increases. So what will happen as the plane increasing its speed, it will tend to pitch down because the AC is moved closer to the CG. So in terms of the stability of the plane, we can say that it will become less negative relaxed static stability at higher speed, which is not good, because the plane is tend to become less unstable at high speed. We want the plane to be unstable for the fighter plane, as I mentioned to you, negative RSS. So as the speed are increasing, you can see here, as the speed increases, the SC is moved backward closer to the CG, so it will be 10 less pitch up. So in other words, because the distance between SC dengan CG is become closer, so it is less responsive compared to what to do at the low speed. So at the low speed, the plane is more negative RSS compared to when it at high speed. All right. So that is disadvantage of having the backward swept wing. So the backward swept wing meaning that the SC will move backward closer to the CG. So it become less unstable condition, which is not good for the fighter plane. So it is same as well for the F-14. In F-14 is even worst case, because during high speed F-14 use dia punya swept wing, okay, to fly faster. The F-16 actually will swing backward kan, alright, for high speed. So at high speed, the AC will become further backward, so we become closer to the CG, so it become less unstable at high speed. So which is not good for the fighter plane. Alright. So that's why kalau you aware, there are some version of F-14 which is designed with what we call is glove vane. Not all, ada certain, the testing, the design, the F-14 built in with glove vane. So what to wing is swing back, which is AC is much closer to the CG, which is become less unstable. So the glove vane will be retracted, akan keluar. So this glove vane actually will so-called create an additional lift kat depan, and as well will be create the unstable condition, especially when it increase the high angle of attack, because they can create a vortex flow over this glove vane. So it is more or less macam legs lah, tapi it is not efficient as the legs as we discussed previous slide. Tapi just for your info, the glove vane of F-14 with glove vane ni cuma been developed few model saja, few units saja, because the complexity of the system, because you need to be retracted at the high speed when the wing is swing back, kan. Jadi and very costly and maintenance and etc. So this idea was scrapped after some unit, and it back to the normal original type of F-14 without the glove vane. So that's the things lah. So what about the stability of X-29 and Su-47, which are Russian made, Berkut of the Russia? Alright, it's more complex to discuss this one. InsyaAllah, kalau ada peluang, I will discuss this in episode akan datang, because you will be surprised. This type of plane is very unstable, and is very responsive in terms of the maneuverability. So this plane are categorized as a super maneuverability plane because of the negative RSS condition for the swaying, because as the speed increases, dia punya SU move away daripada sini.
PM.
Jangan bunyi pula. Okay, with that I'll end my talk today. Hopefully insyaAllah we'll see again next time. Okay, Assalamualaikum.